Welcome to DriverDTrains. Thanks for stopping by. I'm your host, DriverD. We're joined again today by our conductor and brakeman, Scratchy-C. Recently, I completed a series of videos on using DCC-EX EX Rail to automate our trains. We learned what EX Rail is, what it can do, and how we can use it. We also created two different sets of automations to control our trains, including automations to control two locomotives working together in tandem to switch freight cars from one track to another. In order to assist both new and returning viewers, I have compiled all the videos from the series into this one Supercut so that you can have the complete set all together in one place. The resulting video is quite long. To assist with navigation through the various parts, I have included a table of contents at the beginning of the video, as well as individual chapter markers in the bottom left corner of the screen. Be sure to check this video's description for links to the original videos in the series, as well as a community post with all the script for today's automations so that you can try them out for yourself on your layout. Also, if you are enjoying the videos, please leave a comment and hit the like button. And if you haven't already, be sure to subscribe to the channel. And I hear the conductor's whistle calling, so let's get started. Automating trains in DCC-EX EX Rail Supercut. Here are all our train orders for today. Part 1. Creating automations in DCC-EX EX Rail. In my last video, we ran a full operating session on my D-Saver layout. As I mentioned in video number 6A, Meet the D-Saver 1 foot by 6 foot HO scale switching layout. Each time I finish an operating session, I notch up the throttle on the locomotive, release the brakes, and sound the horn as the locomotive heads off the layout. After going through this routine manually several times, I decided that while I enjoyed the show, I didn't really feel the need to drive the train myself every time. So I decided to create an automation to do it for me. An automation is a routine or sequence of events that happens on its own following a specified set of instructions without requiring a person to manually perform those actions. Basically, automations allow us to control our trains and layouts as if we were playing a player piano. Automations can be used for many different things. We can use them to control our locomotives, operate turnouts and switches, control lights and signals, play sounds, and control animated features on our layouts, among other things. There are a number of different ways that we can make automations for our model railroad layouts. In my video number 5E, using physical controllers with JMRI and DCC-EX, I demonstrated how to create an automation using computer macros and a Stream Deck controller. We can also program simple development boards like the Arduino to control animations and other features on our layouts. And there are commercially available products to control things like grade crossing signals and track sounds, for example. And we can create various types of automations in JMRI. But for those who run their trains using DCC-EX, the easiest and most useful way to create automations is to use the EX Rail automation module that is built into the DCC-EX EX Command Station software. That is how I decided to automate running my trains off the layout at the end of each operating session on the D-Saver. And the Roll Out automation I used to do that is the example that we will start with in these videos. But first, let's have a quick introduction to DCC-EX EX Rail and talk a little bit about how to plan an EX Rail automation. Here's what's on the menu in the dining car today. For an appetizer, we'll start with an introduction to EX-Rail, the automation component included within DCC-EX, to find out what it is and how it works. For the main course, we'll talk about how to plan an automation in EX-Rail, and look at some of the specific EX-Rail features, including sequences and aliases, that will help us plan and create our automations. Finally, for dessert, we'll run some trains. All this talk is making me hungry, so take a seat and let's get started. Creating automations in DCC-EX EX-Rail. Part 1. An Introduction to EX-Rail. What is EX-Rail? EX-Rail is a set of DCC-EX features to help us automate our railroads that is included within the EX Command Station software. When Greg Berman first introduced DCC++ to the world in 2015, he said that one of the reasons that he created DCC++ was that he really wanted to automate running trains on his layout, but he couldn't do that with his existing DCC controller. If you haven't already, be sure to check out Greg's DCC++ channel here on YouTube, where you can see his automated 3-loop N-scale layout in action. If you look closely, there's even an automated oil derrick next to one of the structures. I discuss further how Greg designed the DCC++ system in my video number 4X, DCC-EX bonus materials. I'll include a link to the DCC++ YouTube channel in this video's description. When the DCC-EX developers took over the DCC++ project in 2020, updating the automation features of DCC++ was one of the driving factors behind their decision to rewrite the DCC++ Command Station code and create what we now know as EX Command Station and its automation component, EX-Rail. The Extended Railroad Automation Instruction Language, or EX-Rail for short, is the DCC-EX module for creating or scripting automations for our layouts. EX-Rail allows us to write simple automation scripts using basic text instructions that the DCC-EX command station interprets and runs on our layout when directed to do so. We don't have to be a programmer or learn complex code to use EX-Rail, but some basic understanding of how to create a simple set of step-by-step instructions to obtain our desired results is helpful. We'll look at this together as we discuss how to plan an automation in this video, and then create the rollout automation together in the next video. What can we do with EX-Rail? EX-Rail allows us to control many different types of automations on our layouts. We can control automations that run our trains, control switches and turnouts, operate signals, display messages on LCD and OLED displays, play sounds and animate lights and moving features on our layouts, such as crossing arms, semaphores, turntables, machinery, and more. EX-Rail includes dedicated commands for these features, as well as ways to create our own commands. There are commands for controlling our locomotives and tracks, signals and turnouts, turntables, sensors, and other inputs, outputs and LEDs, servos, and DCC accessory decoders, among others. EX-Rail also includes a number of commands that allow us to control the flow of our automations or the order in which the instructions in our scripts are carried out. There are also conditional statements, such as if, then, else, that allow us to determine whether or not and when our scripts should run. EX-Rail can also display messages on our LCD and OLED screens, as well as send information to Y-throttle controllers and JMRI. There are some basic things, however, that we cannot do in EX-Rail. For example, EX-Rail does not allow us to create or work with variables, although we can create text constants using the alias command. So we won't be doing any math in our EX-Rail scripts. We also won't be using any for loops, while loops, or counters. EX-Rail also does not provide a way for any interactive input from the user during the operation of an automation. So, for example, we can create an automation to run our train around the layout a certain number of times, but we can't ask the user to enter the desired number of trips around the layout that they want the train to make when they activate the automation from their throttle. Instead, we have to decide ahead of time how many times to run the train around the layout, or else offer the user multiple options to choose from. One to run the train around the layout once, another to run it twice, and so on. We will use this option ourselves in our examples. It is also important to note that EXRail only works on the Arduino Mega microcontroller or an ESP32 board. The Arduino Uno does not have enough memory for EXRail to run along with the rest of the DCC-EX command station software. We won't go into all the details of EXRail in this series of videos. In fact, we'll barely scratch the surface of what we can use EXRail to do. We'll dig a little deeper in my next video, but you can find information about all the EXRail commands and functions and examples on how to use them on the DCC-EX website. I'll include a link to the EXRail page on the DCC-EX website in this video's description. How do we use EXRail? Scripting or programming in EXRail is done using simple text commands in the myautomation.h sketch, which is part of the DCC-EX EX command station software. For these videos, we will edit this sketch using the Arduino IDE. If you've been following along from my other videos, you may recall that we first created a simple automation using the myautomation.h sketch in video number 4D, Configure DCC-EX Wi-Fi for Station Mode, and then added our locomotive roster to the myautomation.h sketch in video number 5D, using Y-throttle and engine driver with JMRI and DCC-EX. If you haven't previously created a myautomation.h sketch tab, we will do that together in the next video. Although we could create all our automations directly in the myautomation.h tab, eventually we may have many different automations, and having them all in one sketch could get messy and confusing. Just as the different components of the DCC-EX software are written across many different sketches and tabs, we can do the same thing for our automations and put each automation or group of similar automations in its own tab if we like. We'll do this by adding #include statements in the myautomation.h sketch. This will help keep our work organized and clear and make it much easier to update and change our automations in the future. Again, we'll look at how to do this together in the next video. Then, in our myautomation.h sketch, along with any other included tabs, we will list all the various EXRail commands and functions that we want our automations to perform. To organize our work and allow EXRail to understand what we want to do, we will group our commands and functions into collections of related instructions called sequences. We'll look at sequences further in a moment and put them to use when we create our automation in the next video. Once we have created our automations, there are a number of different ways that we can activate or run them. For example, we can use the Y-throttle and engine driver apps to activate our automations. We can also run our automations from the EX Web Throttle app in Google Chrome. And we can use JMRI to run our automations. We can even use hardware controllers like the Stream Deck with JMRI to trigger our EXRail automations. We can also have our automations run automatically so that they are always on, or that they trigger when certain events happen, such as when a turnout is thrown or a button is pressed. We'll explore in detail some of the ways that we can control our automations after we create a few. But now that we have a basic understanding of what EXRail is and how we can use it, let's look at the process for planning out the sequence of steps we want to perform and creating an automation to do them. Part 2. Planning an automation in EXRail. A cake recipe. The example that I will use to illustrate planning and creating an automation in EXRail is a recipe for making a cake. Creating an automation is like making a cake. The script for the automation is like the recipe for the cake. Our recipe needs to include the ingredients, the order in which to prepare them, how to prepare them, and how to know when to proceed to the next step in the recipe or know when the cake or our automation is done. For example, a recipe for baking a cake might instruct us to start by turning on the oven and then grease the pans before we do anything else. That's because whoever came up with the recipe knows that it takes time for the oven to heat up and that we are going to want to pour our cake batter into the pans as soon as it is ready. Continuing with the cake recipe, we then mix up all the ingredients in a specific order following a specific set of instructions. Once the cake batter is ready, we can pour it into the greased pans right away, but depending on how long it took us to mix the ingredients, we may still have to wait for the oven to finish heating. Finally, after we put the cake in the oven, we have to wait a certain amount of time and then check to make sure the cake is fully baked before we take it out to cool. Our automations will do the same kinds of things with our model railroads. The ingredients for our automations will be our trains, tracks, and sensors, and any other items that we want to control on our layouts. Our automation scripts will then tell EXRail what to do with these ingredients and in what order. We can also use timers in our automations and wait for specific events to happen, just like when making a cake. For example, we might tell EXRail to set a timer and then check a sensor or the status of a turnout to see if certain conditions are met before moving on to the next step in our automation, just like checking the oven when the timer goes off to make sure the cake is ready. But a recipe can't just include a bunch of steps we need to take. It also needs to include the steps in the right order and group the steps together in such a way that the recipe is easy to follow. We will also do this with our automations by using EXRail sequences. EXRail sequences. As I mentioned before, automations in EXRail are split up into related groups of functions and commands called sequences. Sequences represent specific parts of our automation that include all the instructions necessary to complete a particular task. Sequences can also trigger or activate other sequences, either because we tell them to or based on other conditions such as the locomotives on the track or the status of turnouts and sensors. Thinking back to our example for baking a cake, turning on the oven and greasing the pan might be one sequence. Mixing up the ingredients to make the batter might be another sequence. And baking the cake in the oven might be a third sequence. Some of these sequences will happen simultaneously, while others need to happen in order, one after the other. We will do the same thing with our automations in EXRail. For example, we might have one sequence that starts a locomotive moving down the track while blowing its horn. At the same time, another sequence might monitor sensors on the track to determine when the locomotive reaches a certain spot in order to tell the locomotive to stop. Those two sequences can run at the same time. However, a different sequence to start a second train down the track might need to wait until the sequence for the first locomotive ends before the sequence for the second locomotive can begin. For another example, suppose we want to create an automation that drives a train around the layout. To do this, we want the train to start, drive around the layout, and then stop. These are the main steps in our automation. But we also want the locomotive to do other things during the automation, like change its speed, turn on and off its lights, and make certain sounds. We can turn each of the main steps we identified, start, drive around, and stop, into a separate sequence in our automation, with each of those sequences containing multiple instructions, such as turning on the headlight, sounding the horn, or applying the brake. Breaking up our automation into separate sequences will help us plan and organize our script and make it easier to create our automations. For example, thinking about our automation that drives the train around the layout, our automation would include instructions to run the start sequence, then trigger the drive around the layout sequence, and finally run the stop sequence. Now suppose we also want to have a version of the automation that drives the train around the layout twice or 3 times. To do this, we can simply copy our first automation and then have it repeat the sequence to drive around the layout 2 or 3 times. We would still use the same start and stop sequences at the beginning and end of our automation, no matter how many times we want the train to drive around the layout. Breaking up our automation into separate sequences also makes it easier to edit or change how the automation works. For example, consider how we might tell our train to drive around the layout. We could tell the locomotive to drive for a certain amount of time. Or we could use a sensor that can detect when the locomotive passes over a certain section of track and use that to determine when it has completed a loop around the layout. By having a separate sequence dedicated just to driving the train, we can easily edit how it works to instruct the locomotive to drive for more or less time, or switch to using a sensor instead. Or we can have two separate sequences so that we can do both and decide which to use based on which automation we run. Driving a train around the layout may sound like a fairly simple and straightforward automation, but it provides us with an opportunity to look at some of the advanced techniques for creating and managing our automations that will serve us well in the future. Planning all the steps and sequences we need for our automation in advance will provide us with the recipe we need to start writing the script for our automation. We'll take that up in earnest in the next video. To help us keep track of all these sequences, as well as other items in EX-Rail, such as locomotives, turnouts, and sensors, we will use EX-Rail's alias feature. Let's take a moment to look at that now. Using aliases in EX-Rail. All objects in EX-Rail, such as turnouts, signals, and sensors, must each have their own unique numeric ID. This also applies to locomotives, which must have a valid DCC address, as well as locomotive DCC functions, which have a decoder function number. Likewise, all EX-Rail sequences must have an ID, which must also be a number. Keeping track of the ID numbers for all these different objects and sequences can quickly become a confusing headache. Fortunately, EX-Rail allows us to refer to these items by using aliases instead of ID numbers. Alias is an EX-Rail function that allows us to substitute one value for another anywhere in our script. We can use this function to give the items we want to control, as well as our EX-Rail sequences names. For example, instead of referring to turnout 32, we can refer to the siding turnout. Instead of sensor 117, we can refer to the crossing gate sensor. Instead of activating locomotive function 11, we can activate the locomotive train brake function. And instead of running sequence 901, we can run the start loco sequence. Further, in many cases, we don't even need to pick an ID number for the alias. EX-Rail will do that itself, and we never need to worry about it. It takes a little bit of extra work at the beginning to set up aliases for our automations, but it will save us a lot of time and hassle later on, because if we ever change the ID number for one of the items in our automation, we only need to update the alias once and don't need to update the automation each time we reference that item. So, for example, if we decide to remap the locomotive train brake function to F4, we only need to change the train brake alias from 11 to 4, and don't need to search through our script and change the function every time that we use the train brake in our automation. Using aliases also makes it much easier to plan and follow what is happening in the automation. For example, it is much easier to understand what our automation does when we have sequences called start loco, drive loco, and stop loco, rather than sequences numbered 901, 902, and 903. There are a few limitations to aliases. For example, we can't use spaces or symbols in alias names. Also, we can create any specific alias just once during our automation and can't change it afterwards. So we can't start an automation with the train brake alias set to 11 and then change it to 4 later in the automation. Nevertheless, aliases will be very helpful for planning and creating our automation script, which we will do in the next video. But we've already gone over a lot of information today, so let's take a short break, let some of that information sink in, and then come back fresh and ready to put that knowledge to use. Part 3. Let's run some trains. We have now had a brief introduction to DCC-EX, EX-Rail, learned what it is and what it can do. We also spent some time looking at how we can use EX-Rail sequences and aliases to help us plan and create our automations. And we briefly discussed some of the different types of locomotive throttles that we can use to activate our EX-Rail automations once we've created them. But all this talk is making my head hurt, so let's go run some trains. Part 2. Automating a train with DCC-EX EX-Rail. In my last video, I introduced you to EX-Rail, the automation component that is included within the DCC-EX EX command station software, described some of the things that EX-Rail can do, and provided a basic overview for how we can use EX-Rail to plan and create our own automations. In this video, part 2 in the series, we'll go step by step together through the process of creating a set of automations to run one of our trains. The example we will use is the automation that drives the train off the layout each time I complete an operating session on the D-Saver. We will create 4 slightly different versions of this automation to use depending on how many freight cars are in the train. You'll be able to try out this automation yourself on your own layout and modify it however you like. I'll include the script for the automations in a post on my community page, which I will link to in this video's description. The automations that we create today will use timers and won't require any additional hardware modifications to our layouts to use. In my next video, we'll create a version of the automation that uses a sensor to detect when our train has reached the end of the layout. This is a very simple and straightforward automation that will provide us with a basic introduction to using EX-Rail, but will also allow us to look at some of the advanced techniques for controlling our automations that will serve us well in the future. Here's what's on the switch list today. First, we'll plan out our automation by thinking about what we want to accomplish and in what order. Then we'll dig into programming and testing our automation in EX-Rail and learn how to structure our EX-Rail scripts to keep them organized and easy to work on. After that, we'll look at how to trigger or run our automations using various types of throttles and controllers. And of course, we'll run some trains. Our locomotive is ready, so sound the horn, release the brakes, and roll on out. Automating a train with DCC-EX EX-Rail. Part 1. Planning our automation. Now that we've learned a little bit about what EX-Rail is and what it can do, it's time to start creating our own automations. The examples in this video build on the concepts we discussed in the last video, especially those related to EX-Rail sequences and aliases. Be sure to do a quick review of part 2 of that video if you haven't already seen it or if you need a refresher. While I could simply show you the finished automations and explain what each part does, I think it would be more instructive if we went through the development process for the automations and came up with the scripts together. Thinking back on the example from my last video of making a cake, I could show you the finished cake and then tell you how I made it. But I think it would be better if we made the cake together, step by step. This won't turn any of us into a master chef, but at least we'll get a taste of how a baker works, and maybe that will inspire us to try it ourselves. We'll do the same thing with our automations. I will include the entire script for the automations from today's video in a post on my community page, which I will link to in this video's description. You can try this automation yourself on any section of track on your layout. Be sure to read the comments in the script for the items that you will need to customize to match your locomotive's DCC decoder programming. Before we can do anything else, however, we need to figure out what we want our automations to do. and then plan out how we are going to make that happen. For this example, we want to write a script for a simple automation that will drive the train off the layout at the end of an operating session on the D-Saver. The ingredients for our automation will be the locomotive and freight cars in the train from the operating session, and the track will be our oven. Here's a broad overview for what we want to happen. First, we want to drive the train to the end of the layout. Then we want to stop the locomotive before it hits the wall. After that, we want to back up the train to its starting point and shut down the locomotive. We can turn each of these steps into a separate sequence in our automation, with each sequence containing multiple instructions, such as sounding the horn or applying the brake. If we spend a little time planning our automation in advance, it will make writing the script to perform the automation much easier. We will go into more detail about what each of these steps entails in the next part of this video, but looking at this list, it should be clear that one of the most important things we need to figure out is how to make sure that the locomotive stops before it hits the wall. There are several different ways that we can do this, but for this video, we will do it by using a timer, just as if we were baking a cake. So we will use one timer while the train is driving down the track so that we can tell it to stop before it hits the wall. Then we will use another timer when the locomotive is backing up to its starting point before it shuts down. In my next video, we will look at how to do these things using sensors. One wrinkle that we need to throw into the mix is that the distance the locomotive needs to travel to the end of the layout is not always the same because the number of freight cars in our train is not always the same. As I described in my video number 6A, the outbound train for each operating session on the D-Saver includes one locomotive and from 1 to 4 freight cars, which are randomly chosen by the D-Saver switching puzzle app. The number of freight cars will change the amount of time it takes for the locomotive to get to the end of the layout because the starting point of the locomotive and the distance it needs to travel, as well as how fast it moves, will depend on how many freight cars are behind it. Unfortunately, as I mentioned in my last video, EXRail does not allow us to pass this kind of information to our automations when we activate them from the throttle, which means that we can't tell the automation how many freight cars are in the train when it starts. To get around this limitation, we are going to need to create 4 slightly different versions of our automation with different length timers depending on whether there are 1, 2, 3, or 4 freight cars in the train. This is like a cake recipe that tells us to bake the cake for different lengths of time depending on what size pan we put it in. It is also similar to the example from my last video, where we looked at creating 3 slightly different versions of an automation to drive a train around the layout 1, 2, or 3 times. As with that example, we will use EXRail sequences to help us plan and create our automations. Again, EXRail sequences are groups of related commands and functions that perform a specific task. By using sequences, we can create 4 separate automations from nearly all the same script. For our example today, only the timer information needs to change depending on the number of freight cars. None of the rest of our script does. So by breaking up our automation into multiple sequences and separating out all the timer information, we can plan things so that we write most of our script just once. EXRail sequences are handy tools for helping us script our automations, but they are normally invisible to the user. In other words, they don't show up in a train throttle. Instead, we trigger or activate sequences from within our automation script. However, EXRail does offer 2 special types of sequences that do show up in train throttles: automations and routes. The difference between automations and routes is that when we trigger an automation from our throttle, EXRail automatically assigns the locomotive that is active in the throttle to the automation. Conversely, EXRail does not assign a locomotive to a route. We can still use routes to control locomotives, but the locomotive will not be assigned from the throttle. Otherwise, sequences, routes, and automations are all the same. Thinking back to our plan for driving the train off the layout, we are going to need 4 slightly different automations that will appear in our throttle so that we can select the right one to use when we send the active locomotive on its way with from 1 to 4 freight cars. We can then place the rest of our script in a series of invisible sequences, the same each time, triggered by the 4 automations. I call this set of automations Roll Out. Now that we have a plan, let's get started writing the script. Part 2. Scripting our automation in EX Rail. Getting ready. Now that we generally know what we want our locomotive to do and have some basic idea for how we want to organize our work, let's write the script to make it happen. As I mentioned in my last video, scripting or programming in an EX Rail is done using simple text commands in the myautomation.h sketch, which is part of the DCC-EX EX command station code. For today's example, we will edit this sketch using the Arduino IDE. So we'll start by opening the CommandStation-EX.ino sketch in the Arduino IDE as we have done in prior videos. Then we can use the 3 dots menu at the right-hand side of the tab bar to select the myautomation.h tab. Remember, the Arduino IDE sorts capital letters before lowercase letters, so this tab will be listed near the bottom of the menu. If you've been following along from my other videos, you may recall that we first created a simple automation using the myautomation.h sketch in video number 4D, Configure DCC-EX Wi-Fi for Station Mode, and then added our locomotive roster to the myautomation.h sketch in video number 5D, using Y-throttle and engine driver with JMRI and DCC-EX. However, if you haven't previously created a myautomation.h tab for DCC-EX, we can do that now in the 3 dots menu by choosing New Tab from the top of the list. We need to make sure we name this new tab to be exactly myautomation.h, all in lowercase letters except for the first A in automation. If we are creating a myautomation.h tab for the first time, we also need to type in 2 lines of code at the top of the sketch. The first line will say Auto Start, all in capital letters, and the next line will say Done, also in capital letters. Now, before we do anything else, we need to take some safety precautions. One of the things about automations in EX Rail is that it is easier to start them than to stop them. This could cause problems if our automations don't work as we expect. So we will create an automation that stops all our other automations and sequences from running. This will be like having a fire extinguisher on hand in case our cake catches on fire in the oven. We will make this automation a root so that it shows up in our throttle. So in the myautomation.h sketch, under the lines that say Auto Start and Done, we will type root, all in capital letters, followed by an open parenthesis, then the number 911, followed by a comma, and then the words Stop Everything in quotes. This will create a new root, number 911, that will show up in our throttle with the name Stop Everything. On the next line, we will type Kill All, again, all in capital letters. This will stop the automations and sequences running in EX Rail. Finally, on the next line, we will type Done. We now have an automation in the form of a root that we can use in an emergency, or if something is not working properly with our other automations. Now we could continue to write all the script for the rest of our automations right here in the myautomation.h tab, but eventually we may have several different automations, and having them all here in one tab could get messy and confusing. Just as the different components of the DCC-EX software are written across many different sketches and tabs, we can do the same thing for our automations and put each automation or group of similar automations in its own tab if we like. This will help keep our work organized and more clear, and make it much easier to update and change in the future. So the next thing we will do in the myautomation.h sketch is type hashtag include quotes myautomation underscore rollout.h end quotes. This will tell the Arduino IDE to include the sketch for our new rollout automation, which we haven't yet created, when the IDE compiles the DCC-EX command station code. Now we will create the new sketch by using the three dots menu again and choosing New Tab from the top of the list. We need to make sure that the name for our new tab exactly matches what we typed in the hashtag include statement, with the same capital and lowercase letters. For this example, I named the new sketch myautomation underscore rollout.h with a capital A in automation, a capital R for roll, and a capital O for out. We can check to make sure that the names match by attempting to compile the code in the IDE by clicking on the small round button with the check mark in the upper left corner of the IDE window. If the code compiles without any errors, then the names match. If the IDE gives an error message that the file is not found, then the names don't match. We can either fix the name in the myautomation.h sketch or rename the new tab we just created by using the rename command in the three dots menu. One word of caution about using the rename command in the three dots menu. If we use that command to rename a tab after we have successfully included it in other parts of our sketch, the IDE will not update the hashtag include statements in the rest of our code. Yet the IDE will still include the tab even though the names don't match. This can cause some serious confusion down the line when trying to figure out what the code is doing because the names won't match as expected. Okay, we are finally ready to start writing the script for the rollout automation in our new sketch tab. The rollout automation. Let's start by adding a comment at the top of the page to indicate what we are working on. Remember, we start all comments with 2 forward slashes. Next, we will create some of the aliases that we will use in our automations. Alias is an EXRail function that allows us to substitute one value for another anywhere in our script. In my last video, we discussed some of the advantages of using aliases in our automations and how aliases make it easier to understand what our automations are doing and modify them in the future. We'll start by creating aliases for our DCC decoder functions. Different types of DCC decoders have different locomotive function mappings. The locomotives that I run on the D-Saver are all equipped with Athearn Genesis OEM diesel versions of the Soundtrack's Tsunami 2 decoder. However, I have changed many of the locomotive function mappings to make them easier to use on a wireless number pad in JMRI. When you create your version of the script, you'll want to use the function mappings for your DCC decoders. It may sound like a lot of extra work to do this now, but it will save us a lot of time and hassle later, and will also make following what is happening in the script in this video much easier. Eventually, we will want to put most of our commonly used aliases, such as our locomotive function aliases, on their own myautomationaliases.h tab in the Arduino IDE, so that all of our automations can refer to the same aliases. But for today, we'll just keep them here with our rollout automation script. So before we go on, we'll create our first sequence called setLocoFunctions to store all the aliases for our locomotive decoder function settings. Technically, EXRail identifies all sequences by number, like the number 911 that we gave to our Stop Everything route. However, we can also refer to sequences by name by, you guessed it, creating an alias. So the first thing we will type is alias, all in capital letters, followed by an open parenthesis, and then the name of the sequence we are about to create, set_locofunctions in this case, followed by a closed parenthesis. Note that we don't use quotation marks in EXRail when we declare an alias. Alias names can include letters and numbers, but not spaces or other characters, and are case sensitive. Also note that all EXRail commands, including the alias command, must be written in capital letters. Now we'll create the set local functions sequence. We'll type sequence in capital letters, open parenthesis, the alias we just created for it, set underscore local functions, and then close parenthesis. Again, there are no quotation marks. To end the sequence, we will use the return command. This will tell EXRail to go back and continue with the rest of the rollout automation once the set local functions sequence is done. Let's add some comments while we're at it to explain what we're up to. Now let's set aliases for a few of our locomotive decoder functions. For each decoder function we want to use, we'll type alias, all in capital letters, with the name of the decoder function and its function number in parentheses. We'll pick alias names that are easy to remember. We'll also add comments for each one. We'll start with the basics: headlight, bell, horn, and short horn, which are decoder functions 0, 1, 2, and 3. We also know that we are going to want the independent train brake function, which I have set to function 4 on my locomotives. Since our locomotives may not all have the same function mappings, there may be times when we need to create custom aliases for some of those locomotives. For example, suppose that we have a locomotive, number 123, that still has the independent train brake function set to the factory default of F11. We can create another alias called FN_brake_123 to represent locomotive 123's brake function number 11. We'll add more of these function aliases later on when we need them. Now we can finally get started on the main rollout automation. Eventually, we will need 4 slightly different versions of this automation, but we'll start with just the one for now. Again, we are using an automation sequence for this because we want it to appear in our throttle, and we want it to run using the active locomotive from our throttle. We'll type automation, all in capital letters, followed by an open parenthesis. We then need to assign our automation a unique ID number of our choosing, followed by a comma, and then a descriptive name, in quotes, that will be displayed in our throttle app. Note that we are not going to use an alias here because we want to assign the 4 slightly different automations specific sequential numbers, as we'll see later. For this example, we will give the automation the ID number of 11 and call it Roll Out with 1 car, because we are going to start with the automation we'll use when the locomotive is taking just 1 car off the layout. We then type a close parenthesis to finish the line. We can add a comment after the end of our code to remind us what it is for. Now we can fill in what we want to happen in this automation sequence. We'll start by penciling in some comments, then come back and add the code for the script later. In this case, we want to drive the locomotive down the track, wait for the first timer, stop the locomotive before it hits the wall, back up the locomotive to its starting point, wait for the second timer, and then stop and shut down the locomotive. We then need to end the automation sequence by typing Done in capital letters. We now have a broad outline of what we want our automation to do. Now we can work on the individual steps we want each part of our automation to take. For these next steps, we will use the generic EXRail sequence command because we don't want to see these individual steps listed in our throttle apps. We'll work on these steps one at a time, just the way we plan them. Sequence 1. Drive the train to the end of the layout. The first step we want to work on is the sequence to start the locomotive and its train heading down the track. We'll use an alias to call this sequence drive_loco. We then create the sequence using the drive_loco alias in parentheses. Again, there are no quotation marks. We'll also add the return command to tell DCC-EX to go back and continue with the rest of the rollout automation once the drive_loco sequence is done. We also need to tell the rollout automation to run the drive_loco sequence. We use the EXRail call command to do this, with the alias for our sequence in parentheses. Again, there are no quotation marks. We can add this in front of the first comment we penciled in for the rollout automation. Now let's figure out what we want the drive_loco sequence to do. Let's start the action by displaying a message on our LCD that the locomotive is rolling out. We can do this with the EX Rail LCD command. We'll type LCD followed by an open parenthesis, and then the line number from 0 to 7 that we want to display our message on, a comma, and then the message that we want to display in quotes, followed by a closed parenthesis. In this case, we'll let everyone know that our local is rolling out. We just need to remember not to make our message too long or it will be cut off on the display. Also, because the programming track and the main track on the D-Saver are connected to each other with insulated rail joiners, we want to issue a join command to join the programming and main tracks and avoid any short circuits when cars or the locomotive cross between the two. Now we can send the commands to get our locomotive ready to drive off the layout. We don't simply want the locomotive to start moving. That's not much fun. Instead, we want the locomotive to set the brake and notch up the throttle. After a short wait for the prime mover to spool up, the locomotive should release the brake, sound the horn, and drive towards the end of the layout. Since we don't want the locomotive to take off like a rocket when we release the brake, we also need to make sure that the locomotive's momentum setting is engaged, and that we haven't accidentally overridden it. We can pencil this in with comments in the sequence. Now, we'll tackle these in order. The first thing we want to do is set the brake. That means we are going to start using our locomotive decoder functions. So let's call the setLocoFunction sequence we created earlier now. Once we've called that sequence, we don't need to do it again anywhere else. Now we can set the independent brake by using the FON function with the FN brake alias in parentheses. Just so we can see how it's done, let's also look at how to use the alternate function mapping for the hypothetical locomotive number 123 we created an alias for. To do that, we use the DCC-EX ifLoco command with an else and an end-if statement, so that if locomotive 123 is active, we use its custom alias. Otherwise, we use our default alias. Let's add a short 100 millisecond delay to make sure the brake is really set before we continue. To do this, we'll use the EXRail delay command and enter the number of milliseconds we want to wait in parentheses. Now I mentioned that we don't want the locomotive to take off like a rocket when we release the brake, so it's important that we make sure that the momentum is working. I've got the momentum settings on my locomotive set very high, but there is a half-speed override function that will turn the momentum off, which we don't want, so we need to make sure that the override function is not active when we release the brake. I have that function mapped to F10 on my locomotives. So before we continue, let's add an alias for the momentum override function to our setLocoFunctions sequence. We'll call it FN_momentum. We now want to make sure that the momentum override function is off. So back in our driveLoco sequence, we'll use the FOFF function with the FN momentum alias in parentheses to make sure that the override function is off and the momentum is on. Again, we'll add a short 100 millisecond delay to make sure the locomotive receives our command. Now, let's set the throttle to forward speed 50, which is about 40% of full throttle. To do this, we'll use the forward command with the speed from 0 to 127 in parentheses. One thing to note about speed steps in EXRail is that speed 0 is stop and speed 1 is emergency stop, while speeds from 2 to 127 represent throttle speeds from 1 to 126. So to set the throttle to a specific speed step, we need to add 1 to the setting in EXRail. So we will type FWD parentheses 51 close parentheses to set the throttle to forward speed 50. Then we'll add a 5,000 millisecond or 5-second delay to give the prime mover some time to spool up. We're now ready to release the brake. We'll just use the FOFF command with our FN brake alias. As I said, I've got the momentum settings on my locomotive set pretty high, so let's also add a 1,000 millisecond or 1-second delay after we release the brake so the loco will start rolling. We are now ready to sound the horn. The Tsunami 2 has several options for the horn. We can use the standard non-latching horn, or we can use the latching short horn. For the rollout automation, however, I prefer to blow the grade crossing signal. Fortunately, the Tsunami 2 decoder includes a function for this. On my locomotives, I have that function mapped to F22. So before we continue, let's add an alias for the grade crossing signal to our set local functions sequence. Now we can activate the grade crossing function in our drive loco sequence with an F-on command. And since we only want the grade crossing signal to sound one time, we need to turn it off with F-off shortly after we turn it on. We also need to include a short delay between when we turn it on and when we turn it off. Otherwise, we will turn it off before it has a chance to sound. We'll use 500 milliseconds or half a second for that. We have now completed the drive loco sequence, which is the first part of our rollout automation. Let's add a 5-second delay in the rollout automation just after the call to the drive loco sequence to see how far the locomotive gets at this throttle setting, and then try it out to see how it works. First, let's check our code to make sure there are no errors by using the checkmark button in the upper left corner of the IDE window. It's not unusual to have errors when first compiling an automation script. The most common errors are caused by not using the correct capital and lowercase letters, misspellings, missing commas and parentheses, or alias names that don't match. We just need to review the code to correct any of these grammatical errors that we find. Then we'll upload our new automation to our DCC-EX command station by using the Upload button with the arrow just next to the checkmark button. We can then open the serial monitor in the Arduino IDE. We do this by clicking the icon in the top right of the IDE window that looks like a magnifying glass over a series of dots. Opening the serial monitor will cause the Arduino to reboot. Once the command station reboots, we can try out our new automation. To do this, we need to place a locomotive on the track. For this example, we'll use the same Southern Pacific GP40-2 number 7623 that we ran in our last operating session. Then, on the serial monitor command line, we will type an open angle bracket / start, all in capital letters, the DCC address of our locomotive, 7623 in this case, and the ID number for the rollout automation, 11 in this example, and then close angle bracket. Once we have it all typed in correctly, we'll hit return or enter. Now we can see what we've done. All right, so far so good. We saw the local rolling out message on our LCD display, the locomotive prime mover spooled up, the brake released, and the locomotive started rolling, while the grade crossing signal sounded on the horn. A few seconds later, our automation finished and the locomotive stopped. Note that when an EX rail automation completes, DCC-EX sends an emergency stop command to the locomotive. This sets the locomotive throttle back to 0 and results in a loud air brake crash on the Tsunami 2. We'll want to keep this in mind when we work on the script for the last part of our automation. Now I think we are ready to move on to the next part of the rollout automation. Sequence 2. Stop the locomotive before it hits the wall. Before we work on our next sequence, we need to determine how long we want our locomotive to drive down the track before we stop the locomotive. This will be a matter of trial and error, and we will eventually need to do this for a locomotive pulling 1 car, 2 cars, 3 cars, and 4 cars. For now, though, let's just focus on 1 car. We can easily edit the time the locomotive drives by changing the delay for our first timer in the rollout automation. We saw that the locomotive didn't get very far in just 5 seconds. So let's try 10 seconds. Again, we can upload our sketch to the Arduino and try it out on the command line in the serial monitor. If 10 seconds isn't enough, how about 15? We may decide to increase this even further later, but for now it looks good enough. We can start working on our next sequence to stop the locomotive before it hits the wall. First, let's create our new sequence. We'll call this sequence Stop Loco, so we'll create an alias with that name, then add the sequence command, some comments, and a return statement after. Then we'll call the Stop Loco sequence in the rollout automation. Let's pencil in the Stop Loco sequence now. First, let's update the message on the LCD display to indicate that the locomotive is stopping. Then we'll set the throttle to 0. EXRail offers a stop command to do that. We'll also add a 200 millisecond delay after the stop to make sure the locomotive gets the message. In most cases, that might be enough, but as I mentioned before, I run my locomotives with a lot of momentum, so just issuing the stop command won't actually stop the locomotive anytime soon. And certainly not before it tries to bore a tunnel through the wall. So to get the locomotive to stop, we also have to turn on the momentum override function, which turns off the momentum. Remember, we created an alias for this function earlier because we wanted to make sure that the override was off when we first started our locomotive. Now we want to turn the override on so that the momentum will be off. So we'll use the fON function with the fn momentum alias. This should cause the locomotive to stop right away. Now that the locomotive has stopped, let's get it ready to back up the train to its starting point. For this example, we will have the locomotive back up very slowly in silence. First, let's make sure that if we had the bell on, we turn it off. We'll add a short delay and then turn off the bell. Now let's quiet down the prime mover and silence the locomotive. I have the prime mover RPM settings mapped to F26 and F27 on my locomotives. To notch down the prime mover, we will use F26. First, let's add that alias to the setLoco function sequence. Then we can use the function in the stopLoco sequence. We'll add another delay, then fON to activate the function, and after another delay, fOFF to unlatch the function. This will start shutting down the prime mover. Now we just need to wait for the locomotive to finish quieting down. 18 seconds seems about right. Then we mute the locomotive. I have that mapped to F8, so let's add that alias to the setLoco function sequence and then put it to use. Before we forget, let's turn off the momentum override so we can get the locomotive's momentum back. Again, we need a short delay first. Finally, let's wait one more second before we finish the stopLoco sequence and return to the rollout automation. Let's try our work. As before, we'll upload our sketch and then enter open angle bracket /start 7623 11 close angle bracket in the serial monitor command line. That looks great. Our train moved on out down the track. The locomotive stopped before it hit the wall, and the prime mover shut down. Now let's back up the train to its starting point. Sequence 3. Back up the train to its starting point. This will be an easy one. Let's create a new sequence called back loco. As before, we need an alias, then the sequence, and return commands. Let's also make sure we call the sequence from the rollout automation in the appropriate spot. First, let's show a message on the LCD display that the train is backing up. Now, the only other thing we want to do is have the train back up slowly. We can use the EXRail reverse command for this. We'll try reverse speed 4, which will be speed step 3 on our throttle. That's all there is to it. We're done with this sequence. Let's go back to the rollout automation and enter a delay for the second timer. When we rolled out at speed step 50, we ran for 15 seconds. Let's start by backing up for 30 seconds. I'm sure that won't be enough, but better safe than sorry, and we can always add more later. Let's try it out. Upload the sketch and enter angle brackets /start 762311 angle brackets in the serial monitor command line. Alright, that came back about half the distance. Let's try backing up for 60 seconds. That's pretty good. We're almost there. We can fine-tune it by adding a couple more seconds each time we test it out until it's just right. Okay, let's move on to our final sequence. Sequence 4. Shut down the locomotive. Our last sequence will shut down the locomotive. We'll call this sequence shutdown. Back it up, buddy, gonna shut you down. No, not more singing. Oh, all right. Again, we'll start with an alias, name the sequence, add a return, and call it from the rollout automation. We'll display a message on the LCD that we're shutting down. Then we'll issue the stop command. Now we may not realize it because the locomotive has been muted the entire time we've been backing it up, but the prime mover is running again. So let's shut down the prime mover like we did before by latching and unlatching the FN RPM down function. As before, we want to make sure to add a short delay between function commands to make sure that the locomotive receives them. Now let's turn off the lights. This locomotive has a strobe light and ditch lights in addition to its headlights. These are on F5 and F6. Let's add those to the set local function sequence and then turn off all the lights. Hopefully you can see why we went to the trouble to name all our functions with aliases. If we ever change the function mappings on our locomotive or want to use our automation on a locomotive with different function mappings, we only need to update the set local function sequence and don't have to worry about changing anything else in our script. And while we haven't done it for this example, we could even create aliases for the two timers so we could have different length timers for different locomotives. But I'll leave you to try that out. Okay, what's left to do? Let's add a delay of 8 seconds to give the prime mover a chance to finish shutting down. Now we can turn off the mute function to unmute the locomotive. Now that we can hear the locomotive again, let's play some cab chatter. I have that mapped to F7, so we'll add that to the set local function sequence, then latch and unlatch the function. Then we'll wait 10 more seconds for that to finish. Finally, we'll unjoin the programming track from the main and display our regular message back on the LCD display. And that wraps up our first automation. Let's try it out. We're experts at this part by now.
Dispatcher, CEY-CX, you'll be going in for Amtrak at Springdale, over.
For rollout automations. We now have an automation to roll out our locomotive in one car. But how do we roll out with 2 cars, or 3, or 4? Easy. We only have to copy the rollout automation sequence and adjust the delays. We don't have to change anything else. So we'll just select the lines of script for the rollout automation and copy and paste in a new set. We'll number this automation 12 and call it rollout with 2 cars. Now we just need to edit the delays. Again, this will be a matter of trial and error, but we can start by subtracting about 2 seconds for each additional car when rolling out and about 12 seconds for each additional car when backing up, and see how that works. We'll repeat this process to create automations 13 and 14 for 3 cars and 4 cars. Then we just start the locomotive on automation number 11, 12, 13, or 14, depending on whether there are 1, 2, 3, or 4 cars in the train. It's that simple. We now have the complete set of rollout automations we need to drive the train off the layout at the end of an operating session. That's great, but now we want to use them. So let's look at how we can run them from our throttles. Part 3. Running our automations. Now that we've created our first set of automations, let's look at how to use them. We'll start by looking at the Y-Throttle and Engine Driver apps. We'll also look at how to run our automations from the EX Web Throttle app in Google Chrome. After that, we'll check out how to run our automations in JMRI. Let's start with the Y-Throttle app. Note that we can only run automations from the full version of the Y-Throttle app, not the free light version. Once we have the Y-Throttle app open and connected to DCC-EX and our locomotive selected from the roster, we'll go to the throttle window. Then, in the throttle window, we'll swipe right on the function buttons to see the turnout and route control window. The window will open with the turnout control screen. However, if we click on the small icon in the upper right corner of the window that looks like a circle with 3 yellow dots in it, we will be taken to the route control screen. Here we will see all the automations we just created. These are shown with round icons with 2 red dots in them. We will also see the 911 Stop Everything route we created when we first started that we can use in case of trouble. To send our locomotive on its way, we simply select the automation we want to use. For the rollout automation, we'll select the one with the number of cars in our train. That's all there is to it. We will immediately see the throttle jump to the set speed. If we swipe back to the function button screen and watch, we will see our locomotive's various functions being activated by the automation. Note that we can still control our locomotive while the automation is running, but this could lead to some unexpected results depending on what the automation does. For the rollout automation, if we speed up or slow down our locomotive during the automation, it could end up driving off the layout. So we'll want to be sure to pay attention and be prepared to step in and stop the locomotive or cancel the automations if necessary. The Engine Driver app works very similarly to the Y-Throttle app. We connect to the DCC-EX command station, select our locomotive, and then swipe left on the throttle screen to see a list of our routes and automations. The automations each have a button that says Handoff, while the routes each have a button that says Set. To activate the automation or route, we simply click its button, and off the train goes. Again, if we swipe back to the throttle screen, we can see the throttle and the functions update as the train works its way through the automation. Now let's take a look at the EX Web Throttle app in Google Chrome. First, we need to make sure that the debug console is on. Then we can connect to our DCC-EX command station. If we look in the console window, we will see that the EX Web Throttle app polls the command station to get a list of all our automations and routes. Now, let's select our locomotive. Running an automation from the EX Web Throttle app is just like running it from the Arduino IDE serial monitor's command line, except we don't use the angle brackets. So, for example, to start our locomotive 7623 rolling out with one car, we would type /start 762311 on the debug console command line and press return or enter, or press the send button on the screen. For 2 cars, we would change the 11 to 12, for 3 cars to 13, and 4 cars to 14. Again, if we watch, we will see the throttle slider and function buttons responding as the automation puts the locomotive through its paces. Note that the EX Web Throttle app also has a separate screen where we can see our automations listed. To access this screen, we click on the small button in the upper left corner of the window with the icon that looks like a sideways S, and we will see all our automations and routes listed there. Unfortunately, during my testing, the handoff feature didn't work, but that might be addressed in a future update, so be sure to check back later. We can also trigger our automations in JMRI's Decoder Pro app in much the same way. In my videos number 5E, using physical controllers with JMRI and DCC-EX, and number 5F, managing JMRI locomotive rosters, we looked at some of the JMRI features specifically designed for DCC-EX, including the command line that we can use to send commands to DCC-EX using its native DCC-EX protocol. We use this command line to send commands to DCC-EX just as we did in the EX Web Throttle app. So again, to start our locomotive 7623 rolling out with one car, we would type /start 762311 on the command line and hit return or enter, or press the send packet button. And if we open the DCC-EX traffic monitor window, we can see all the commands being sent to and received from DCC-EX. We also saw in video number 5E how to use physical controllers, including macro pads, such as the Stream Deck controller with JMRI to control our trains. We can set up these devices to send DCC-EX commands using the command line, making it easier to trigger our EX-Rail automations with just a button. It is also possible to create control panels with buttons to activate our routes and automations in JMRI's Panel Pro app, but that is a topic for a future video. Part 4. Let's run some trains. We have now seen how to create a simple automation to drive a train with a locomotive and from 1 to 4 freight cars from one end of the track to the other and then back again using a modular and flexible approach with timers. We will extend this even further in the next video by adding the option to use a sensor. We can use the lessons we learned today to create even more complex and varied automations in the future. But the light is fading and we've done enough today, so let's go run some trains. Part 3. Adding a sensor to our automation in DCC-EX, EX Rail. In my last video, we created an automation to drive a train from one end of the layout to the other and back again. We used timers to tell the locomotive how long to drive and how long to back up, and created 4 slightly different versions of the automation to choose from, depending on whether the locomotive was pulling 1, 2, 3, or 4 freight cars in the train. Hopefully you had a chance to try out those automations yourself on your own layout. In this video, we'll create a version of the automation that uses a sensor to detect when the locomotive has reached the end of the layout. Thanks to our use of sequences and aliases in the last video, this will be a piece of cake, and we will easily be able to modify the automation to use a sensor. The most logical and straightforward way to do this is to add a sensor at each end of the layout where we want the train to stop. Infrared photosensors are commonly used for this. However, because I don't have a good place to mount a photosensor, I decided to use an electrical block occupancy sensor instead. Then, just to make things more interesting, instead of 2 sensors, I used just 1 sensor to detect the train at both ends of the layout. This adds some complexity to our automation, but will give us the opportunity to learn some new tricks we can use in EX Rail. We'll also create a virtual sensor while we're at it, so that we can run the automation even if we don't have a sensor on the layout, which means that you can try out the automation yourself on your layout. Be sure to look for a community post with all the EX Rail script from today's video, so you can try out the automation yourself. Here are all the duty assignments listed on the train board. First, we'll look at how to connect the sensor to our layout and to our DCC-EX command station. Then we'll modify our EX Rail script and add the sensor to our rollout automations. Finally, we'll run some trains. We've got our orders, so let's move out. Adding a sensor to our automation in DCC-EX, EX Rail. Step 1. Add a sensor to our layout. Now that we've seen how to create the rollout automation to drive our train using timers, let's take a look at how we can add a sensor to our layout and use it to control the automation. This will allow us to run just one automation regardless of the number of cars in the train. There are various types of sensors that we can use on our layouts that are compatible with DCC-EX, including photosensors, RFID radio tags, and time-of-flight lasers. But for this example, we will use an NCE BD20 block occupancy sensor, which detects current flowing through an electrically isolated block of track. I'll include a link to the sensor in this video's description. In this case, we will actually use the same sensor for both the starting block and the ending block of track. Because we know that our train will never occupy both blocks at once, we can get away with using only one sensor, although it adds a bit of complexity to our automation. Another complication that comes from using the block occupancy sensor instead of a photosensor is that we need a freight car that conducts electricity at the back of the train to activate the sensor. The locomotive will always activate the block sensor at the ending block of track, But we also need to make sure that the freight car at the back of our train activates the sensor at the starting block. We can do this if the freight car has a resistor wheel set on it, or if it is lighted, such as with a lighted caboose, or if it has an electronic circuit that makes sounds, for example. In my case, I use this yellow rail box with a flashing rear end device to activate the sensor. Again, if we used 2 photosensors instead of just 1 block occupancy sensor, we wouldn't have to worry about this. Alternatively, we could just let the train back up until the locomotive enters the starting block. However, on the D-Saver, that would send the freight cars sailing off the end of the layout, so we'll find another solution. Connecting the block occupancy sensor to our DCC-EX command station is very simple, as it connects to the Arduino with just 3 wires. One wire runs from the +5 to 12 volt connector on the sensor to one of the 5 volt pins on the Arduino, and a second wire runs from the GND connector to one of the ground pins. The third wire for the sensor output runs from the logic connector on the sensor to one of the digital input-output pins on the Arduino. We don't use the relay connector on the sensor for the automation. For this example, I have connected the 5 volt wire and ground wires to 5 volt and ground pins in the header socket at the back of the Arduino Mega, which is the side opposite the USB connector, and the logic wire to pin 30, which is also in the socket at the back. We'll need to know that last one for our automation script. We'll also need to make sure that the starting and ending blocks of track are electrically isolated from the rest of the track on our layout. I used plastic rail joiners to do this, but we could also just gap the rail. We only need to do this for one rail, although I isolated both rails since I also used the starting block as the DCC programming track. Finally, we'll need to run the track feeder wire for the isolated blocks of track through the middle of the detection ring on the sensor and loop it around the ring a turn before connecting it up to the track. Alternatively, if our feeder wires are small enough, we may be able to loop 2 of them through the sensor ring rather than connecting the 2 blocks of track together. In either case, we need to make sure that the track feeder wire for each block is connected to the appropriate track main power lead because we don't want any short circuits. That completes adding the sensor to our layout and connecting it up to our DCC-EX command station. Now let's add the sensor to the rollout automation. Step 2. Add the sensor to the rollout automation. Now that we've connected the sensor to our layout and DCC-EX command station, let's look at how we can use it in the rollout automation. Our new automation will use the same sequences as the other rollout automations we created in the previous video, so we'll start by copying one of our other automations and assign it the number 10. We'll call it rollout without specifying any number of cars. Then we just need to replace the delay timers in the automation with sensor checks. To check for a sensor, we use the EXRail @ command along with the Arduino pin number or an alias of the pin number that the sensor is connected to. For example, if we had simply used a photosensor or something similar at each end of the layout and connected them to pins 30 and 31 on the Arduino, we could create 2 aliases called start sensor and end sensor, and then replace the first delay in our automation with an @end sensor command and the second delay with an @start sensor command, and we'd be done. The train would drive down the track until it triggers the sensor at the end of the layout, then stop and back up until it triggers the sensor back at the starting point where it would shut down. It's that simple. We're going to make things much more challenging. Let's jot down some notes and then we'll come back and fill in the script. First, because we are using a block occupancy sensor and don't want the train to back off the layout, we should check at the start to make sure that there is a freight car at the starting block that the sensor can detect. That way we'll know that the sensor will detect the train as it's backing up, and the automation will know to tell the train to stop and shut down before it backs off the layout. But what should we do if the sensor does not detect a freight car? We could simply cancel the automation. But instead, how about we ask the engineer if they want to proceed anyway? We'll look at how we can do this with a virtual sensor. Once we know that it is okay to start, we call our drive loco sequence just as we did in the last video. Then, once the train is rolling, we need to wait for it to clear the starting block before we check to see if it has reached the ending block. That is because we are using the same sensor for both blocks of track. Once the train clears the starting block, we'll wait until it triggers the sensor again when it reaches the ending block. We then call the stop loco and back loco sequences. Then we wait for the locomotive to clear the ending block and back up to the starting block. When the freight car at the back of the train reaches the starting block, we call the shutdown sequence. That will complete our automation. Now, let's go back and enter the script to do those things. First, let's create an alias for our block sensor. That way, if we ever connect the sensor to a different pin, we only need to update the alias. Next, we want to check if the sensor can detect a freight car at the starting block, and if not, we want to ask the engineer what to do. We can use the EX-Rail if not command to check if the sensor is not being activated by a freight car. If the sensor is active, our automation will skip the next steps and proceed to the drive loco sequence. But if the sensor is not active, we'll display a message on the LCD that no train is detected, and then sound 2 short blasts on the horn to get the engineer's attention. Then we'll wait for up to 10 seconds for the engineer to manually trigger the sensor. We can do this with the EX-Rail @timeout command. The @timeout command waits for up to a specified amount of time for a sensor to activate before moving on. We'll wait up to 10 seconds for the engineer to activate our block sensor before continuing. We'll talk about how the engineer can activate the sensor in a moment. But first, we add the if timeout command after the @timeout command. This lets us decide what to do if the engineer never activated the sensor during the time we waited. In this case, we'll restore the LCD to its original message, unjoin the main and programming tracks, and end the automation without going any further. However, if our sensor did see the freight car at the starting block, or if the engineer manually activated the sensor, we will continue with the drive loco sequence from our previous automations. This will start the train moving down the track as the locomotive sounds its horn. We are also going to add a 6-second delay, which is about how long it takes the locomotive to start moving in the drive loco sequence before we check the sensor again, to minimize the chance that we get a glitch in our sensor reading. I have found that sometimes when the freight car starts rolling, the sensor reading cuts out for a split second, which makes the automation think that the train has reached the end of the layout, when it is actually still at the starting block. By waiting for the train to start rolling, we reduce the chance of a false reading. Now we need to make sure the train clears the starting block before we check to see if it has reached the end of the layout. Again, we wouldn't have to do this if we used 2 sensors, but where's the learning in that? There are 2 possible scenarios we need to consider. The first scenario is that the sensor saw the freight car at the starting block. The second is that it didn't, and the engineer triggered the sensor manually. Again, we can use the @timeout command with a very short delay this time, say 200 milliseconds, to check if the sensor can see the freight car on the starting block. If the command times out without seeing the freight car, we can assume that the train is on its way and we can start watching for the locomotive to enter the ending block of track. However, if the sensor sees the freight car still on the starting block, then we need to wait for it to clear the block. We can do this with the EX-Rail after sensor command. This instructs our automation to wait until after the sensor clears when the freight car leaves the starting block before going on. Now we just wait for the sensor to see the locomotive when it enters the ending block. Again, we do this with the @sensor command. We'll add a short 1.5 second delay to let the locomotive get fully into the block, then call the stop loco sequence from our prior automations. This will stop the train at the ending block. Then we'll call the back local sequence to start the train moving back towards its starting point. We'll wait 1 second to make sure the train is rolling again, backwards this time, and then use the after sensor command to wait for the locomotive to leave the ending block. Then we use another @sensor command to wait for the freight car to return to the starting block. We'll add another delay, 15 seconds this time, to let the freight car get all the way into the starting block, and then call the shutdown sequence. That's it! Our train can now run from one end of the layout to the other and back again using a sensor. Now, let's talk about how we can let the engineer manually trigger the sensor if the freight car doesn't do it. First, there is the physical option. If the freight car is on the track but not triggering the sensor, the engineer may be able to move the car a bit to get the sensor to see it. However, we can also create a way for the engineer to trigger the sensor manually in the automation by using the EX-Rail latch command. In fact, this method will work even if we don't actually have a sensor, which means that we can create a virtual sensor. To allow the engineer to activate this virtual sensor, we will create a route that will show up in the throttle that the engineer can select to trigger the sensor. We'll create an alias for our route and then the route itself. We'll display a message in the throttle that the rollout automation is OK to go. Note that this route will run independently from the rollout automation and is not called from within the rollout automation. Rather, we activate the route in our throttle and can do so anytime we want, even if the rollout automation is not running. Therefore, we will end the route with a done command rather than a return command. Next, we'll display a message on the LCD display that the rollout automation is OK to go. Then we'll use the EX-Rail latch command to manually trigger our sensor. Note that this is a virtual sensor and does not actually do anything to the physical sensor. It just makes EX-Rail think that the sensor is activated. Then we'll wait 1 second and unlatch the sensor, after which our route automation will finish. However, by briefly latching or activating the sensor with our route, the rollout automation will get the message that it is OK for the train to proceed down the track, even if it doesn't see a freight car at the starting block. Note that we will need to activate the route in our throttle again when we are ready for the train to stop backing up at the end of the automation, since there is still no freight car to trigger the sensor. We could even take this a step further and run the automation without any sensor at all, by using the OK to go route to start and stop the train at each end of the layout. While letting the automation do all the other things in between. We'll explore these types of hybrid automations further in the next video.
Hold it first stop for me. Got the maintenance way up pity there. Should be clear in any minute there.
But that job can wait until next time. So put away your notepad and let's go find our train. All aboard! Step 3. Let's run some trains. We have now seen how to create a simple automation to drive a train with a locomotive and from 1 to 4 freight cars from one end of the track to the other and then back again using a modular and flexible approach with both timers and sensors. We can use the lessons we learned today to create even more complex and varied automations in the future. We'll look at an example in the next video. But we finished our duty assignment for today, and with that we're done. So let's go run some trains. Part 4. Switching the Christmas Tree in DCC-EX EX Rail. Hey, Scratchy! I heard that people like to watch videos of trains running under the Christmas tree during the holidays. Maybe we should make one of those videos. Yes, I know Christmas was last week, but we still have the tree. No, I can't make it go in circles. Tell you what, how about we make a video showing folks the switching automation for 2 locomotives we'll be creating in DCC-EX EX Rail in our next video. All right then, let's get switching. Bonus switching video number 2. Switching the Christmas tree in DCC-EX EX Rail. This automation features 2 locomotives working together to switch 3 freight cars from one track to another. It could easily be adapted to as many cars as we like. The automation actually consists of 2 separate automations, one for each locomotive, that work together in tandem. These automations are also what I refer to as hybrid automations, meaning that EX Rail handles all the engineer's duties while the operator works as the switchman, manually coupling and uncoupling the cars and throwing the turnouts. Let's see how they work. The action starts with the locomotive on the lower siding. Its job is to spot the freight cars one at a time at the end of the right-hand spur. A festive red CP4405 is working the siding today, so we'll assign it the Spot Cars job and dispatch it to DCC-EX to handle the rest. The locomotive will shove its train forward until the freight car is on the spur. Then, after we uncouple the car, the locomotive will back up on the spur to clear the turnout. That's the signal for our second locomotive to join in on the action. This locomotive, SP7623 today, is working the switch cars job and has been waiting patiently on the main for its turn. It needs to pull forward past the switch, then back onto the lower siding and grab the freight car from the spur. It then pulls out onto the main and past the turnout to the upper spur. Then it backs into the spur. It needs to slow down as it shoves the freight car around the bend. Then, once it drops its car, the locomotive can pull back onto the main and return to its holding spot. Dun dun da da dum da da dum da da dum 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 da da dum da 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 dum doodle da da dum dum. Oh, what was I saying? Then the process starts over as the first locomotive spots the next freight car, and so on. Let's watch. Locomotive bells clanging all the way. Oh, what fun it is to drive a GP40 today. Hey! Excuse me. All the locomotive functions, including the lights, the horns, the bell, and the coupler sounds, are handled by the automations. The automations can also switch all the turnouts. I use manual switches on the D-Saver layout, but we'll look at how to control the turnouts when we create the automation in the next video. After the second car has been switched, the first locomotive spots the third and final car. It then backs to the far end of the siding and shuts down. Scratchy, the brakeman, was a jolly furry soul, with a crooked bite and a whiskered nose and 2 eyes yellow and gold. Oh, excuse me. Finally, the last car has been switched, and the second locomotive also returns to its starting spot and shuts down. Another successful delivery completed under the Christmas tree. Ho, ho, ho!
Dispatch 11 over. Hey, number 11, you have locomotive maintenance. Give us a call about the leader. I'll let locomotive know. Thank you. Out. Dispatcher out.
Part 5. Automating 2 locomotives in DCC-EX EX Rail. In this video, we'll develop a set of automations to control 2 locomotives as they switch 3 freight cars from one track to another. One locomotive will set out the cars, one at a time, while the other locomotive will grab each car in turn and switch it to another siding. This automation will actually consist of 2 automations and several sequences that work independently. We'll control these automations using timers, so we won't need to add any additional hardware to our layout, which means that you can try out the automations yourself on your layout. Be sure to check out the previous videos in this series if you'd like an introduction to or a refresher on how EXRail automations, sequences, and aliases work. Here are all the switching moves we'll be making today. First, we'll plan out what we want our automations to do and create a new sketch for them in the Arduino IDE. Then we'll create the Spot Cars automation script for the first locomotive. After that, we'll tackle the Switch Cars automation for the second locomotive. And of course, we'll run some trains. We've got our switch list, so put on your gloves and let's go make some cuts. Automating 2 locomotives in DCC-EX EX Rail. Part 1. Planning our automations. Before we write our script, let's create the new blank sketch we need in the Arduino IDE and then plan what we want our automations to do. First, we'll open the command station ex.ino sketch in the Arduino IDE as we have done in past videos, and use the 3 dots menu at the right-hand side of the tab bar to select New Tab from the top of the list. We'll call our new sketch tab myautomation_switchcars.h with a capital A for automation, a capital S for switch, and a capital C for cars. Then we can use the 3 dots menu again to select the myautomation.h tab. Remember, this tab will be listed near the bottom of the menu. In the myautomation.h sketch, we'll type #include myautomation_switchcars.h to include our new sketch when the IDE compiles the DCC-EX command station code. Again, we need to make sure the spelling exactly matches the new tab we created. Now, we'll navigate back to that new tab by selecting it in the tab bar or by using the 3 dots menu and start planning out our automations. We'll just use comments to pencil in the broad outlines for what we want to happen. We'll start by planning out the Spot Cars automation for the first locomotive. Since this automation will start first, we'll take care of any initial housekeeping that we need to perform before the trains start running, such as setting signals and clearing the track. Then we'll work on the locomotive itself. We'll use EX rail sequences for the locomotive actions. The locomotive will start at the end of the left-hand spur on the lower siding with several freight cars coupled on in front of it. We'll use 3 cars for this example, but we can use as many as we like and have room for on the layout. Since we don't want the locomotive to simply start from a dead stop with no preamble, the first thing we will do is run a sequence to start the locomotive. In this video, I will be using Athearn Genesis 4-axle GP locomotives with Tsunami 2 sound decoders, ditch lights, and beacons, so we'll create a suitable startup sequence for those locomotives. After we run the startup sequence, we can proceed to the main sequence for the first locomotive to spot the freight cars one at a time. The real action will begin when the locomotive drives forward onto the siding and shoves the first car onto the lower right-hand spur. First, we'll make sure that any turnouts the locomotive needs to cross are set correctly. Then we'll create a sequence of events, including horns and bells, to start the locomotive moving forward. And we'll use timers to tell the locomotive how long to travel. Then we'll tell the locomotive to stop using another EX rail sequence. After a delay to allow the switchman to uncouple the cars, the locomotive will back up. We could have the locomotive back up to its starting point, but we really only need it to back up about halfway down the siding so that its train of freight cars clears the turnout and then stop. 2 car lengths should be about right. At that point, the locomotive will signal that it is time for the second locomotive to take its turn. The first locomotive will then wait for a similar signal from the second locomotive, and then repeat the process to spot the second car, making a few adjustments since it is not starting from its initial staging point. Since we backed up 2 car lengths after spotting the first car, pulling forward 3 car lengths should put the next car right where we want it. Then, after receiving the signal to spot the third car and completing that job, the first locomotive will back up to its starting point and shut down. All in all, that's pretty simple. Now let's take a look at the second locomotive. We'll call the automation for the second locomotive Switch Cars. This locomotive will start on the main line on the right-hand side of the layout. When it receives the signal from the first locomotive, it will go through the same startup sequence. Then it will begin a sequence of steps to grab and switch the first freight car. First, we'll make sure that our turnouts are set correctly. Then we'll have the locomotive pull forward on the main line, pass the turnout to the lower siding, and then stop. Then we'll throw both the turnout on the main and the one on the lower siding and back the locomotive into the spur to grab the first freight car. Next, we'll check to make sure that all the turnouts on the main are set the way we need them for our next move. After a short delay to allow the switchman to make sure the freight car is properly coupled on, the locomotive will pull out of the spur and drive down the main past the turnout to the upper siding. Then we'll stop the locomotive, throw the switch to the upper siding, and back the locomotive and freight car onto the upper spur. We don't want to go too fast. After backing a suitable distance, we'll again stop, wait, and then pull forward out of the spur and onto the main. Then we reset the switches on the main and back up the locomotive to its starting point. After that, the second locomotive will signal the first locomotive that it has completed switching the first car and is ready for the first locomotive to spot the next car. Then the process repeats. After it finishes switching the third and final car, the second locomotive will back up to its starting point and shut down. We'll then clear any signals and set the track to resume normal operations. That completes the switch cars automation. Thinking back to the example we used in the previous videos, creating our automations is like making a cake. The cake we are making today will have many layers. At the top will be the two automations that we will see in our throttle. On the next layer below those will be the two sequences that will do all the work, as well as the sequences to start up and shut down the locomotives. Below those will be the sequences that make the locomotive drive forward and reverse and stop. Finally, on the bottom layer will be the sequences that sound the horns 2 or 3 times, depending on whether the locomotive is moving forward or backing up. Now that we know what we want our automations and sequences to do, let's write the script to make it happen. Part 2. The Spot Cars Automation. Now that we have a plan, let's write the EX Rail script for the first locomotive. We will use a number of the techniques that we explored in previous videos, as well as some new ones to control the flow of our automations. For example, when we planned our automations, we identified a number of times that each locomotive would have to signal the other that it was done its job and ready for the other locomotive to proceed. We can use a virtual sensor for this, just like we did in video number 7C, adding a sensor to our automation in DCC-EX EX Rail, except that instead of the engineer triggering the virtual sensor in the throttle, the locomotives will trigger the sensor to let the other know that it is time to switch the next car. So the first thing we will need to do in our new automation is create an alias for our virtual sensor. We'll call it the spotting signal and assign it the value of 200. As always, we'll add lots of comments to explain what we're doing. Also remember that we have to explicitly define the alias values for sensors. We also know that we will be lining and throwing several turnouts or switches as the two locomotives traverse the layout. We'll want to create aliases for those as well, and then define the turnouts. DCC-EX offers commands for several different types of automated turnouts or switches, including DCC turnouts, motor or servo-driven turnouts, and magnetic solenoid or pin-based turnouts. Explaining how to connect all the various types of turnouts to DCC-EX is beyond the scope of this video. Moreover, I do not use automated turnouts on the D-Saver, instead operating them manually by hand. However, DCC-EX also offers a virtual turnout, which behaves in EX Rail and shows up in our throttle just like a real turnout. So for this video, we will be using virtual turnouts. Since these are virtual turnouts, we don't need to specify a specific DCC address or pin number for each turnout. So we'll let EX Rail choose when we create the aliases. We'll create an alias for each turnout on the layout. Then we'll define the turnouts using the aliases we created. One other important thing to note is that we will be using the locomotive DCC decoder function aliases from the rollout automation that we created in video number 7B, automating a train with DCC-EX EX Rail. If you do not have that sketch tab included as part of your Command Station EX sketch, you will need to create those aliases at the top of this sketch tab where we created the spotting signal alias. You can find the necessary script with the aliases in a post on my community page. Now we can create the Spot Cars automation. We will actually split this automation into several pieces, an automation to show up in the throttle, and then several sequences to do the work spotting the cars. We'll give the automation the number 201 instead of using an alias, just in case we want to test it from the command line, the way that we did when we developed the rollout automation in video number 7B. We'll end the automation with a done. Then we'll use the EX Rail unlatch command to clear the spotting signal virtual sensor so that the second locomotive does not get the idea that it is already time for it to take its turn. We also saw that the locomotives need to keep track of which freight car they are switching. The first locomotive in particular needs to travel different distances for each freight car as its train gets smaller. As I mentioned in video number 7A, creating automations in DCC-EX EX Rail, EX Rail does not allow us to use variables or counters. However, we can create makeshift variables and counters by using another EX Rail feature, virtual track blocks. By manually reserving and freeing up these virtual blocks, we can keep track of which freight car the locomotive is switching. So the next thing we will do in the Spot Cars automation is reserve the virtual track blocks we plan to use as counters so that they are ready for the start of the automation. We do this with the EX-Rail reserve command. We'll reserve blocks 1, 2, and 3 for the 3 freight cars we'll be switching today. We'll free the blocks one at a time as we switch the cars. Now we're ready to start up the first locomotive. To do this, we'll create and call a new Startup Loco sequence. We'll create an alias for the new sequence and then the sequence itself. As a reminder, in this video, we will be creating a startup sequence for Athearn Genesis diesel locomotives with Tsunami 2 sound decoders. Different locomotives with different decoders would require a different startup sequence. Since we've now done this for 4 videos, I won't go into all the details about what each locomotive function does, but for this sequence, we'll start up the locomotive prime mover and wait for it to spool up. Then turn on the strobe lights, ditch lights, and headlight. We'll also remember to add delays between our function commands to make sure the locomotive receives them. Then we'll end the sequence and return to the Spot Cars automation. We have now completed all the startup actions for the first locomotive and are ready to begin the real work. First, we'll display a message on the LCD to let the engineer know that we are spotting the first car. Then we'll free the first block to let the other sequences in the automation know the same thing. Then we'll call the sequence that will actually drive the locomotive and spot the cars. We're going to make a separate sequence to do this so that we only have to write it once for all 3 cars we plan to spot. When we planned out the automation, we saw that if the locomotive pulled forward 3 car lengths, spotted a car, and then backed up 2 car lengths, it would be in the position to do the same thing again for the next car. So we'll call our sequence forward 3, back 2. We'll work on that sequence next. This sequence will do all the work driving the locomotive. We'll start with an alias, then create the sequence. Along the way, we'll create additional sequences for specific tasks that we'll repeat over and over. First, let's make sure that we line the lower right-hand turnout using the alias we created earlier. We use the EX-Rail close command to line the turnout for the straight route. The lower left turnout should already be set properly since we have freight cars sitting on it, and we won't be using it at all during this automation, so we won't worry about trying to set it now. Next, we'll activate the Tsunami 2 decoder's coupler sound. I hardly ever use this because it is such a boring sound that it's not worth the bother, but it doesn't take any effort to let the automation do it, so why not? We do need to add an alias for it somewhere. For this video, I will add it to the other function aliases we created for the rollout automation. I have the coupler sound set to decoder function 13, which is the factory default on Athearn Genesis locomotives. Now we're ready for the locomotive to drive forward. Throughout the automation, we are going to have both locomotives drive forward, stop, and drive backwards many times. So we will create sequences for each of these actions. We'll call these sequences Spot Loco Forward, Spot Loco Stop, and Spot Loco Reverse, although both locomotives will use the same sequences. So we'll call the Spot Loco Forward sequence to start the locomotive driving forward, and then create the sequence. As before, we'll create the alias and then the sequence. We'll turn on the bell, set the brake, and notch up the throttle. Speed step 8 should be fine for switching operations given the short distances we need to travel. Remember, we have to add a 1 to the speed step in EX-Rail, so we'll enter forward 9 for speed step 8. Next, we'll sound the horn 2 short blasts to indicate that the locomotive is moving forward. We'll create a sequence for this too, called Horn Forward. We'll toggle the decoder's short horn function on and off with a small delay to sound 2 short blasts, then return to the Spot Loco Forward sequence. All that's left now to get the locomotive rolling is to release the handbrake, and we're off. Now we can return to the forward 3, back 2 sequence with our locomotive driving forward. Our goal now is to get our locomotive into position where the last freight car at the far end of the train is about 3 car lengths from the end of the spur where it needs to be spotted. Because we are spotting the first car, the locomotive needs to pull forward a bit to get into that position by driving for about 2 seconds. So we need to let EX-Rail know that we are spotting the first car. We can do this by checking the status of the first virtual block we created to see if it is free by using the EX-Rail if-reserve command. It's a little counterintuitive, but this command actually takes action when the virtual block is free. You may recall that we freed the first block immediately before calling the forward 3 back 2 sequence. So we'll use if-reserve to check if block 1 is free, and if it is, wait or delay for 2 seconds for our locomotive to get into position. We add an end if to move on. Now we just need to wait for our locomotive to drive forward for another 3 car lengths. That takes about 16.5 seconds for my Athearn Genesis units. Then we're ready to stop the locomotive with the Spot Loco stop sequence. Let's create that. We'll stop, set the brake, and turn off the bell. Then return to the forward 3 back 2 sequence where we came from. Now we'll wait a couple of seconds, activate the coupler sound again, and wait 6 more seconds for the conductor and brakeman to finish uncoupling the freight car we are spotting. Then we start the locomotive moving backwards 2 car lengths by using the Spot Loco reverse sequence, which we'll create now. This is very similar to the Spot Loco forward sequence we created earlier. We'll again turn on the bell. This time we'll sound 3 short blasts of the horn to indicate that the locomotive is moving backward. Again, we'll do this with a sequence, this time called horn reverse. We'll again use the short horn for the first 2 blasts, but we can't use it for the 3rd blast because the short horn is a latching function, and the next time we want to use it, we would have to remember that the function is already on and we need to turn it off. So instead, we'll sound a very short blast of the regular horn. Then we'll return to the Spot Loco reverse sequence. Now, back in the Spot Loco reverse sequence, we'll release the brake and set the throttle to reverse speed step 8 by using the EX-Rail reverse 9 command. Our locomotive is moving backward, and we can return to the forward 3 back 2 sequence. Now we'll wait for our locomotive to drive backward for about 2 car lengths or 12 seconds. This is where our locomotive will stop and wait after spotting the first and second cars. However, after spotting the 3rd car, the locomotive needs to back up to its starting point. We can again use the if-reserve command, but for virtual block 3 this time, to check whether the locomotive is spotting the 3rd car. If it is, we'll wait for an additional 14.5 seconds to let it keep backing up on the spur. We're nearly done now with the forward 3 back 2 sequence. We'll call the Spot Loco stop sequence to stop the locomotive, wait 5 seconds, and then latch the spotting signal virtual sensor to let the second locomotive know that we are ready for it to come and switch the first car. We can now return to the Spot Cars automation, where we'll wait for the second locomotive to switch the first car so that the first locomotive can spot the next car. We'll do this by using the After Spotting Signal command. This will tell the first locomotive to wait until after the second locomotive unlatches the spotting signal before the first locomotive gets back to work spotting the next car. Then we just repeat the same set of steps to spot the second and third cars. We've already written all of the sequences, so we don't need to do any of that work again. After we spot the third and final car, we don't need to wait for the second locomotive. We can just shut down the first locomotive. Again, we'll do this with a sequence. We'll turn off all the lights, shut down the prime mover, release the brake, and play some cab chatter. With that, the Spot Cars automation for our first locomotive is done. Let's take a moment to try it out. For this example, we'll use Union Pacific 643, a GP38-2 that may still be in service on the UP. We'll couple on 3 boxcars for it to spot. Because we haven't written the script yet for the second locomotive, let's temporarily comment out the two after spotting signal commands and instead insert a 10-second delay at those locations. That way, we can run the first locomotive through the entire automation without needing signals from the second locomotive. Then we'll upload our sketch to the Arduino command station and wait for it to reboot. There are some different ways that we can test the automation. We can use the Arduino IDE serial monitor command line and type open angle bracket /start 643 201 close angle bracket like we did in video number 7B. That will send locomotive 643 out to complete the spot cars automation number 201. We can also assign the locomotives to their jobs using the Y-Throttle and Engine Driver apps. In Y-Throttle, we'll select a locomotive, then go to the throttle screen and swipe right to go to the turnout manual control screen. We can then select the route screen by clicking on the round icon with the 3 yellow dots near the upper right-hand corner of the screen. Now we select the Spot Cars automation we just created, and our locomotive will begin following the instructions we provided. We can now dispatch the locomotive to the command station and let it run on its own. We need to do this before the locomotive starts moving, because releasing the locomotive will temporarily set its throttle to 0. To dispatch the locomotive in the Y-Throttle app, we click on the green button at the bottom of the screen to go back to our locomotive roster. We then hold down the release button near the top of the screen for a few seconds. This will bring up a menu with 4 buttons. We'll click the dispatch button at the bottom, and our locomotive will now run the automation on its own. We can do the same thing in Engine Driver by selecting the locomotive from our roster, then swiping left on the throttle screen to find the route screen. We find the Spot Cars automation in the list and click Handoff. We can then go back to the throttle and select and release the locomotive. It will now run on its own through the automation. We have now completed the Spot Cars automation, which is the first half of our cake. Now let's work on the Switch Cars automation for the second locomotive. Part 3. The Switch Cars automation. Now let's work on the automation for the second locomotive. We'll give this automation the number 202 and call it Switch Cars in the throttle. Again, we'll create an automation for the top level of our cake, then a sequence to do all the work. Fortunately, we can use all the same lower level sequences to start and stop the locomotive for this automation too, so we won't need to create those again. The automation will start with the second locomotive waiting for the first locomotive to finish spotting the first car. We'll use the @spotting signal command for this. Then we'll display a message on the LCD that we are switching the first car. Since this is the first car, we'll also call the startup local sequence. Then we'll call the main sequence that will do all of the work for locomotive 2. We'll call this sequence grab car. As a reminder, for this sequence, the locomotive will pull forward on the main, back up to grab the freight car from the lower spur, pull forward down the main, and then back the car into the upper spur before retracing its steps to its starting point. So we'll start by lining or closing the turnout on the right-hand side of the main. Then we'll use the spot local forward sequence we created earlier to start the locomotive moving forward. After letting the locomotive drive for a suitable time, 15.5 seconds in this case, we'll call the spot local stop sequence to stop the locomotive. Then we'll throw the turnout and call the spot local reverse sequence to back into the spur, again for about 15.5 seconds. Then we'll stop, play the coupler sound, and wait for the conductor and brakeman to couple on the freight car that the first locomotive spotted. Now we're ready to pull on down the main. We'll make sure that the middle and left main turnouts are lined correctly, then drive forward for 26.5 seconds and stop. Then we'll throw the middle turnout and reverse into the spur. After we get the freight car partway into the spur, we'll briefly stop and then back up more slowly, going around the curve. We want to do this because we don't want to crash into any cars we previously spotted. Since we only need to do this once, we don't need to create a sequence. We'll just use the reverse 3 command to back up at speed step 2. We'll also make sure the bell is on and use the horn reverse sequence to sound 3 blasts. After we back up slowly for another 19 seconds, we'll stop and allow time to uncouple the freight car. Then it's forward and back onto the main. We'll line the middle and right-hand side turnouts on the main and back up to the second locomotive's starting point. Then we stop and set the brake. Finally, we unlatch the spotting signal to let the first locomotive know that we are ready for it to spot the next car. Then we end the sequence, returning to the switch car's automation. Now we just wait for the spotting signal to indicate that the first locomotive has spotted the second car. We update the LCD and do it all again for the second car and eventually the third car. Finally, after the last car is done, we shut down the locomotive and reset the virtual track blocks and LCD to their original state. And that marks the end of our automation. As before, we can test it out by commenting out the @spotting signal commands and inserting short delays. Then we're ready to re-upload our sketch to the command station. Then we can use the command line in the Arduino IDE or our Y-Throttle or Engine Driver apps to send the second locomotive out to switch cars. We have now completed both of our automations. We can uncomment our at and after sensor checks and delete or comment out the delays we added for testing purposes. Then we'll upload our sketch to the Arduino one last time. And with that, we're ready to run some trains. Part 4. Let's run some trains. We now have the 2 automations and all the sequences we need for 2 locomotives to work together to switch freight cars from one track to another. Along the way, we learned some new techniques for controlling the flow of our automations so that they work together in tandem. Now, at last, we're ready, so let's go run some trains. We'll start by assigning the locomotive on the lower siding to the Spot Cars automation. Then we'll release or dispatch that locomotive and select the second locomotive that is waiting on the main to run the Switch Cars automation. Then we put on our gloves, grab our tools, and get ready to couple and uncouple cars. All aboard! If we want, we can come back later and make some changes to the automation to streamline it a bit. For example, the first locomotive could be spotting the next car while the second locomotive is still switching its car. Then the second locomotive could head straight away to grabbing that car rather than heading back to its starting point. We can also easily modify the automation by changing the timers to fit different track plans and layouts and change the number of freight cars we switch. But save all that for another time because right now we've still got 2 more freight cars waiting to be moved. Part 6. The Switch Cars Automation, Bonus Streamline version. In my last video, the 4th in my series on using DCC-EX EX Rail to automate our trains, we developed together the Switch Cars automation to control 2 locomotives working together to switch freight cars from one track to another. In this bonus video, I'll demonstrate the Streamline version of the automation that I described at the end of that video. The full automation lasts about 12.5 minutes. The Streamline version runs for 8.5 minutes. The Switch Cars Automation Bonus Streamline version. We'll start by dispatching the locomotive on the lower spur to the Spot Cars Automation. Next, we'll assign the locomotive waiting on the main to the Switch Cars Automation. After that, we grab our tools and get ready to couple and uncouple cars. The Streamline version makes a few changes to the original version by having each of the two locomotives signal the other sooner to start their respective jobs. As a result, the first locomotive can be spotting the next freight car, while the second locomotive is still switching the previous car. Then the second locomotive can immediately head back to the lower siding to pick up the next car, rather than return to its starting point on the main each time. In the Streamline version, both locomotives are constantly moving. This really keeps the switchmen on their toes, as they have to make sure that all the turnouts are set and couple and uncouple cars much more frequently. But enough chatter. Let's run some trains.
the BN, look for a lighter. Signal indication BN, thanks.
What's next? DCC-EX in 2025, EX CSB1, and more. It's been 18 months since I started my series on assembling a DCC-EX command station, and a lot has changed since then. If you were watching closely today, you may have noticed that I was controlling the layout and running all the automations with the new DCC-EX EX CSB1, the all-in-one plug-and-play command station and booster that DCC-EX announced in December 2024. In my next video, we'll take a closer look at the EX CSB1, as well as how to set it up and program it using the Arduino IDE. We'll also look at how to assemble a DCC-EX command station using an STM32 Nucleo board and an EX motor shield. After that, we'll look at how to add a second LCD to our DCC-EX command station and use that LCD to display information about our locomotives. Be sure to subscribe to the channel so you don't miss any of those upcoming videos. And check this video's description for links to my other videos, including my video series on assembling a DCC-EX command station and my series on using JMRI's Decoder Pro app to control our trains. It's been a long journey to get here, but we've only just begun. Get some rest now, because we'll be setting off again soon. Until then, thanks for watching. Well, Scratchy, are you ready for our next assignment? Let's go find the yardmaster and get our next orders. All aboard!